All right, so I want to sort of wrap everything up today. And what this is going to do, I think these themes I'm going to talk, these are the themes I could think of for the course. There may be others that feel free to add your own, but I think if you keep these themes in mind, what you're studying, it'll help you think about what kind of things you could put, or I could ask an essay question, but you could put into an essay question. So the first thing is, in fact, the nervous system is counterintuitive in a lot of respects about how it's organized. Would you design a system like this? Okay. I mean, would you build a system if someone said to you, build a nervous system? Like if you're building robots, let's say it's a Westworld. When's season 2 of that start? I don't know. Excited though, I love that show. That was pretty cool. Show that says there's no such thing as consciousness. It's like it speaks to me. Would you do motion and object perception separately? You might. I don't know. I've never designed a visual system, so maybe you would. But it's counterintuitive that it works that way, especially counterintuitive to what our experience is, right? We talked the other day about the binding problem, the idea of the hard problem of consciousness, the idea of how do we put all this stuff together and it fits together seamlessly. It doesn't seem like we're perceiving objects and objects in motion as separate things, yet we know that our visual system does that. Would understanding of language be separate from language production? And we know that understanding of language is in Wernicke's area. Right about there. That doesn't help anybody on the podcast or on the video. I don't care. And then temporal, right down here for Broca's area, that's production. Seems odd, right? So, and those are just general examples, but it's a counterintuitive thing, the way the nervous system is built on a gross level. On a micro level, I think it actually is kind of cool. I don't know if I could think of a better way to design a neuron. I think it's pretty cool. But the way that the general system is built is weird. And I think that's why I know that is because it's an evolved system. There is no designer. It's counterintuitive because this is an evolved system. I think because of the organizing principle of all of biology being the modern synthetic theory of evolution by natural selection, synthetic because you put gene genetics together in there and you put evolutionary theory in together. It's an evolved system. So you look at the eye. Look at the eye in a human. What a strange piece of gear this is. There's no way you would make it so we have a blind spot. That's crazy. Right? But it evolved that way. It evolved that way because we have a pretty good idea of how vision evolved. Right? And I can give you a pretty quick and dirty explanation. If you had some skin cells, right, that were sensitive to light. That's not a stretch. There are animals that have patches in the back of some lizards have patches in the back of their heads that are sensitive to light. And what if, well, some mutation happens and then it starts to focus a little bit. It becomes kind of a hit. It's going to be a bit better. And what if then some more skin grows over top of it and there's a pinhole in it to focus the image? Oh wait, hey look, we're designing an eye. You can see how that's going to work, but if you were building the eye from first principles, just building it, you would not put it in a blind spot, but it's an evolved system. The other day I talked about how consciousness might have evolved from our spatial sense. That's a theory. I'm not, and there's no way anybody can actually know the answer to this. It's a good guess. Do we know it's true or not? No, we have no clue. And until my time machine is built, and I've already said too much about the time machine. I'm not building a time machine, I'm kidding. I've always wanted to put in like an insert grant for a time machine just to see what happens. But that would take real time, and I'm not going to do that. So our spatial sense, and then we're not up in the trees anymore, we're on the ground. Evolution then co-opts our spatial sense about knowing where we are, and we evolve to have this pretty special and probably uniquely human type of consciousness. Do other animals have, are other animals experiencing life, having sort of sensory experiences that they know that they are separate from the universe around them? Perhaps. I think probably a lot of primates do. I wouldn't be surprised at all. I think there's something to be said for there being something like consciousness in some other animals, not all the sums, all the hedging in there, but I would bet money that no other animal has the same kind of experience we have. And you can't prove me wrong, so it doesn't matter. So the other thing about it being evolved is if we understand function, we can help understand mechanism. What does this do? Can help us understand, and that's a very general sort of principle of biology, is that if we look at something from a functional perspective, we say, how would we solve a certain problem? The other day we talked about the different streams in the visual system and how we have, what and when and where, what and where and how, right? And what evolved first. And then we thought, and when you guys all thought about what evolved first, you said, well, where is going to be the one? Right, of course. Well, fair enough. So knowing that something is done separately from something else helps us understand that we might be looking at, say, different systems. So when I talked about the spatial cognition stuff the other day, I said that we could look at geometric processing separately from looking at the processing of a feature. So we may be looking, in fact, at different, in that case, I called them cognitive modules. If you want to call them systems, you can. So we can look at function, and it helps us understand something about mechanism. Makes us make guesses about mechanism. I think that, and I'm not going to dance around this. The other thing is that if you look at the human nervous system or any sort of system in the human biological system, it's pretty clear either there's no designer or the designer was stupid. Right? And if you're religious, you wouldn't think the designer was stupid. That wouldn't be cool. So what you'd say is probably no designer. Right? So I mean, it's not about design. It's not about intelligent design. It's about evolution. It's an evolutionary thing. Unless he had a sense of humor, or really, which the platypus. I've heard a lot of my religious friends say that the proof of there being a God is that the platypus exists, because that means he's got a sense of humor. And I mean, it's hard to argue against that one. What a weird animal. You ever seen one of these things? I'm just saying. Yeah, it's got a duck face, but it also has poison, quills, and it lays eggs. But it's a mammal! Okay. If there's a God, he's got a sense. Let's go with she. She's got a sense of humor. So, one of the big themes, I think, as well, is that we have learned a lot about function from dysfunction. So we know that V1 sends information out because of studies about blind sight that I talked about just the other day. Right? We know there's blind sight. So, and we know that happens when people have V1 damage. So V1 must be sending out and making sense of visual input. It's still getting it just isn't sending it to the right place. Right? The case with the artist was his nickname, the initials JM, I think might have been, couldn't see color. We know V4 then must be doing color, because when he had V4 damage, he couldn't do coloring. Couldn't see it, couldn't even imagine it, and changed his life for the worse for at least a year. We know early on about localization of things. That it wasn't the whole brain always doing everything at the same time, that different functions were localized in certain areas because of Mary Rafferty. People always say they always give credit to Bartholomew, I think was his name. I don't want to even give him credit, he was mean. Hey, look at this, I've got a person, ha ha ha. He was a jerk. So I'm going to give Mary Rafferty the credit on this. But remember, when her cortex was stimulated, she ended up moving part of her body or having certain experiences. And the same thing with Penfield's work. When people were, Dr. Penfield, I smell burnt toast. And that's a very good impression. You should look that up. Just Google, I smell burnt toast, Dr. Penfield. You'll find the Heritage Minute from the 1990s, and you'll go, oh, Dave is very out of date with his cultural references, but this is a good impression. So that told us that it was localized, which of course I think has led some people to, with this sort of, you only use 10% of your brain. That's when you quit. That's when you walk away. You don't talk to those people anymore. Or you say, what 90% would you like removed? That's the one I usually use. What 90% would you like removed? Yeah, exactly. You use the whole thing. I can't believe that one persists. That neuromyth, that persists. It really bugs me. Like, it's just so patently false that a small child should be able to look at that and go, well, no. You don't use the whole thing all the time, but it's always working. HM, I talked about HM, he told it, HM gave us really the idea about memory systems existing, about there being different kinds of memory, episodic and semantic memory. Remember, HM comes into the lab at Montreal Neurological Institute, and he's tested on mirror tracing, right? And he gets better at it, and that's great, way to go, HM. And then he leaves, and then he comes back the next day, and he doesn't remember Brenda Milner. He doesn't know who she is. But when he tries mirror tracing, the ability to do it is preserved. Oh, that's cool. And it led us to the idea that there are memory systems. So we can go from looking at different neural systems to saying, looking at behavior. We're looking at brain behavior, hence the name of the course. HM, the case of HM, and later on the case of KC, which I don't want to talk to KC. He had a motorcycle accident. He died recently. So did HM. HM died in 2000. I never remember his name. Other people know his name. I mean, you can use his name now, but he's been called HM in the literature for so much that I just call him HM. Most people. That led us to think about memory and the importance of hippocampus. Right? And for it to consolidate episodic memories. One of the underlying themes, I think, and I don't touch on this too much because I have a bias this way and I try to stay away from it, but as an animal researcher, and I know most people aren't interested in non-humans, they're interested in humans. Though, here's a plug, next year there will be a special topics course in animal cognition. You should take it. It's going to be awesome. I am just saying. But think about Galvani and then you go to Levy, a couple guys work with frogs. Galvani hooks the frog leg up to a lightning rod because he could. I think that's probably the only reason he did it. What do you want to do today? He's Italian, so that's my generic, bad, offensive Italian accent. Let's hook the frog leg up to the lightning. So he did that. And then remember Levy. So I will pour this on the heart, and I will collect the Vegas stuff. That's my German. I got two Germans. There's that guy who gets increasingly mad, and his voice goes higher. And then this one just talks like this the whole time. Neither of them, of course, are good impressions, and they're kind of offensive. But let's move on. So Galvani, Levy. There's a couple of guys who work with frogs that told us very basic things about how the nervous system works. Working with frogs, not even with something not a mammal, for example. There's been tons of lesion work where what you do is you do some experiment, you teach some sort of memory thing, then you lesion a part of the brain off the hippocampus, and then you find that the animal can't do it, whatever it is, usually remembering something, if it's a hippocampal. There's the idea of blocking long-term potentiation in hippocampus and how that usually blocks learning. Using blocking the neuromodulator NMDA and then you don't get learning. Except under very specific circumstances. So it's really important in learning. And now with lesions, there are now techniques available for doing reversible lesions. Now they're not lesions so much as they are ways of turning parts of the brain on and off by cooling them, for example. Right? Which is, I think I showed you that video of hippocampus being cooled in a round-headed cowbird in real time. So you cool it down enough that it stops working for a while. And then the animal does a task and you turn it back on. Pretty amazing stuff. Pretty amazing stuff. Right. So that's something that is very cutting edge. That's a technique that's been used in cats and now in cowbirds. It's going to become much more popular, I think, as a way to do things. It's early days for that stuff. Most of that work's being done in London. So that's all invasive stuff, right? Cutting open a frog heart and pouring solution on it, or a frog chest and pouring solution on its heart is a rather invasive procedure. Putting a cooling loop in a cat's brain is an invasive procedure. Blocking LTP is an invasive procedure. These are all things that I guess you'd call them wet neuroscience. Okay? Some people call it that. But non-invasive work is important as well. The stuff on visual fields. So remember I talked about how, in general, you're better at labeling, reading words with your right visual field because it goes to the left part of your brain, which is better. And you're better at doing spatial tasks with your left visual field going to your right part of your brain. Right? And we know that also from split brain patients. That's what was first discovered. But we don't have to use split brain patients. We can actually just put things in one or the other visual field. The spatial cognition work, the stuff I've done and many other people in humans, is completely non-invasive. Right? So it's not like you're doing something where you have to even have anybody, say, drink radioactive Kool-Aid, radioactive glucose. Right? There's nothing like that. It's just like, just do this task. I can then infer a neural mechanism or a cognitive module, if you want. A lot of neurological tests. I talked about the idea of, well, think about all these case studies we talked about the other day. When someone can't name this object but can see what it is, we don't have to do a test there that's invasive, right? Well, that being said, the person has some kind of lesion on it. But a lot of neurological tests, in fact, the vast majority of them that neurologists use aren't invasive. They are, and this includes MRI, which is a non-invasive procedure because you don't have to drink necessarily. Any kind of tracker, sometimes you do, but the tracker isn't going to be radioactive. But a lot of neurological tests, if you ever had a concussion or something like that, or a suspected concussion, you go to a neurologist. They do a bunch of tests, and it's not like they're doing brain surgery on you. What they're doing is they're basically, like I said, having you name objects, things like that. So there's a lot of things like that you can do that can tell you a lot about neural function, but you don't actually have to do anything that involves cutting anything open. Like I said, MRI as well, which is a non-invasive procedure. Looking at someone thinking. We think of MRI usually as a diagnostic tool. Well, you probably do. I don't. I think of it as a science toy. And it's something that you can watch people think. Well, frankly, you can watch birds think. At the Advanced Facility for Avian Research at Western, they literally have an MRI for birds. It's a small one, which is kind of great. First thing you say to the birds is, do you have any metal on you? Please take out your earrings. Birds don't have ears. Oh, well. Well, they have ears. It's just that they're like that. Oh, you ever heard that? From what I understand, the nervous system is both hierarchical and parallel. Last time I checked, This, in fact, has been a running theme in the whole course, obviously. The vision stuff, I think, is now that we've got to the end of the course, I think the greatest example of hierarchical and parallel is vision. Right? It's a really nice example of a system that's hierarchical and parallel. We, in fact, the other day figured out how the red triangle detection thing would work. And where each part would happen in the brain, right? The parallel part is obvious. We've got two streams going on. That's right there. Dorsal and ventral stream. Done. That's easy. So that's parallel. We can say that. There's also the fact that within each level of the hierarchy, input is being read at the same time. States of cells are being read at the same time. Right? Your whole retina, the state of your whole retina is being read at the same time. And the other idea, another nice example of the notion of the parallel aspect of the nervous system is the fact that is the Hebbian idea of the cell assembly. The idea of a pattern of activation of cells that are interconnected can represent something. So it's a pattern of activation of a bunch of cells represents something in our nervous system. Yeah? The central nervous system, the peripheral nervous system, and the autonomic nervous system. So we say there is a nervous system, and then let's do this for hierarchy. Nervous system at the top, the nervous system. Then below it, you got boxes. Central nervous system, peripheral nervous system, autonomic nervous system. Within peripheral, now let's go below central, we got brain, cerebellum, spinal column. Peripheral, I don't think I can do that for that. Autonomic, sympathetic, parasympathetic. There's a hierarchy, right? One's above the other, but all that's happening at once. My central nervous system is sending messages to allow me to walk around my peripheral nervous system. I'm thinking of the words that I'm going to say next. And the idea comes out 300 milliseconds. It happens 300 milliseconds before they actually come out of my nose, but it doesn't feel like that. Cool. P300. P300. I never did that before. I feel kind of embarrassed. Sorry. Sometimes I listen back to these things, right? Like a year later. Because it's like, how did I attack that this year? How did I attack that the year before? Oh, there's some new material. Where will I put that in? And I go, I can't believe I'm such an idiot. It's like, I've probably done like I've probably been on about 1,700 podcasts. I'm not making that up. I do a lot of that's not my hobby. I have 7 podcasts. And it's still weird hearing my voice, and it's like, I can't believe I said that. Oh, that's going to be offensive to someone. So all these things are examples of how the nervous system is hierarchical and parallel. So I think if you keep these things in mind when you're studying, you get a really good idea of how to attack an essay question. Any questions so far about what I talked about today, or even other stuff? Anything else? You probably don't have anything specific yet. It's still technically November. Not technically. It still is November. Well, technically it's November. You are technically correct, which is the best kind of correct. I can quote Futurama with the best of them. Anybody have that? Now, on Monday, we'll do Q&A. So get studying, get using the Facebook group, etc. When I say thank you, I really mean it. I love my job. I kind of love it. Even when I hate it, it's still pretty good. Even when my left eye is closed and I can't hardly see, even more than I can't hardly see normally, I still love it very much. And coming in and teaching this class and seeing all you guys every couple of days, and especially seeing how I know that this stuff is daunting for some. Seeing how the psychology students dealing with biology and seeing the biology students dealing with psychology. It's fun at teaching a cross-listed course, is that I get to teach biology students psychology and psychology students biology, and at the end they all pretty much have the same level of knowledge. But especially seeing that you have learned things is pretty cool. And I know you have, because a lot of you guys have a lot to be proud of. You've done pretty well so far, and there's still 35 points left, so there's still room to grow. I hope to see many of you Monday if you have questions, but if not, I'll see you at the final exam. I hope to see you in other classes too in the future. And I just want to say thank you very much. It's been an honor to teach you. Thanks, guys.